Okay, right, are the angles out here?
That's perfect. Ready?
Yep.
Oh, landed on your head and everything.
Okay, you go. Okay.
So, here?
Yeah, oh, wait, the camera's wrong.
Are you kidding?
No. Chapter 4.
Trigonometry.
So, sort of similar to what we did in Quarter.
Yes, in fact, a lot of the same stuff is expected knowledge, so we'll quickly go over that before we learn the new stuff.
Yeah, I think we're going to need a really large pair of axes.
Yes, we are. So if you want to draw them up, I'll take back this hat.
Oh, okay.
I think I can rock it better.
So, remember the three graphs, sine, cos and tan, you'd be very familiar with.
Yes, and degrees and radians of each of them.
So we'll go through all of them right now.
So sine starts at 0, 0. It does that, and that would be 180 degrees.
It would.
And it would be a full cycle at 360 degrees. And of course, the mirrored version
In the other side. This way.
And that's sine.
That is sine. Then there's cos x, which is just important, but goes through 1, which is the height, how high this goes.
Yep. Again, it has a period of 180, except it starts here at 90 and 90 because it's going through 1, 0, 0, 0, and looks exactly like Triv has just beautifully drawn.
Like that.
That's cos, and then of course there's tan.
Yep.
And we need blue.
Do you need blue? And this is one with lots of asymptotes where the graph doesn't exist.
Yes, and these asymptotes are at every 90, which is where this cos graph crosses, and it does that shape, and it verges but never touches the asymptotes.
Yeah.
That's what it is.
Tends towards as it goes towards.
And that would keep going for every. Again, it's a cycle of 180, but starts at every 90, finishes at every other 90. That's
Yeah,
it.
and 180 isn't just 180, because we have radians as well.
So if in 360 you should know there's 2 pi radians,
Yep.
that would make 180
Pi.
and
this point
90
here,
half
half
pi,
or pi over 2.
Yes.
And that's just stuff from core 2. There's a few other things from core 2 you need to remember. A couple of relationships.
Yep.
So what tan is.
Yep, and that's sine theta over cos theta, and then you've got the sine squared theta plus cos squared theta equals
1.
Then you've got stuff like you've got to know off the top of your head or be able to work out quickly what cos 30, cos 45, sine 30, sine 45 is.
That sort of thing. So you need to refamiliarise yourself with that. Oh, there we are. And then we can start using the stuff we've already gone over, which is the inverse things.
Yes, the inverse is a bit horrible, really.
It is a bit horrible. It still works like it did in chapter 1, where it reflects across the y equals x line, but it just looks a bit weird with these geometric graphs.
It does. If I draw back up our axis, I'll draw back in a dotted sine graph.
Yeah.
In green, say. I'm making it 1 to 1, you'll notice.
We're giving it a domain that's quite short.
Because if it went over like that, it would be many to 1.
Then we couldn't invert it. And it more or less sits across the y equals x line.
Yes, if we draw in that y equals x line as a solid line, it's like that.
You can sort of see what it's going to do. It reflects just over, so in that way it will go around this way, and this one it will go around this way.
Yes. So in the end, it looks like the sine graph in the x direction, but flipped into the y direction.
Yeah, and it's pretty much the same, well it is the same for the other two graphs.
Yes.
And that's pretty much all the starter knowledge, but it doesn't stop there.
Fortunately not, because inverse sine does not mean 1 over sine.
No.
Because 1 over sine means something else.
It does, and that something else is what we're going to go into right now.
Yeah, let's go do it.
Alright, give me that hat.
That's my hat!
So Wayne, where did you put that hat?
What hat?
Didn't I have it before? I was wearing it and you ran off and took it.
Oh, the one over there, I ran up over there.
Is that Wilfred?
I think it is. Yeah.
Yeah, he's not dead. Yeah, so, something more.
Yes. So, unfortunately, there's more graphs to learn, with more names to learn, and a few more relationships.
A few more. So just before, we had sine to the -1x inverse graphs. But that's not quite the same as sine x to the -1.
No. Because that means these other graphs we're about to go through, and they're called sec, cosec, and cot.
Yeah, I need to show which one's which.
Yes. So, we'll draw up some graphs.
First, we'll write out what these are. They're in the corner, but I'm a bit bigger.
Yes. Sec, cosec and cot. Sec is the 1 over cos. You might think sine because it's the s, but it's cos. Cosec, the one that you probably think is cos, is sine. And then the other one is tan, and that's cot. Cot equals 1 over tan. So these two are perhaps the other way around to what you'd think, but the other way around to what I'd think at least. That's what they are.
Ta-da. And they look different too.
They do. So these two version, they look similar. So I think we'll just draw the cos one and then the sec one. And then you'll be able to see what the cosec one looks like in relation to the sine
sort of thing. Already axes that.
So you know what the cos one looks like. We've just drawn that, and you should know it anyway.
It goes through one.
You just draw that.
It has a normal sine shape.
Now, sec, if you think of it as there's being asymptotes here, like this, it's sort of the upside down version here, then here, and here, and so on.
Yeah, and every time there is a bump, let's say, there's another bump beating it, sort of like clenched teeth.
Yes, much like that. And now the sine one would be just the same, except shifted over this way, so I'm not going to draw both, and now you can see what I mean. You'll know what the cosec one looks like.
Yeah.
Just the reverse of the sine. However,
tan's a little different because it always is.
Yeah, it's different as it is, so it's different is very different to the difference.
Different. So, draw the normal tan graph up.
Again, we've just drawn this and you should know it, but just in case. It goes through the 0, 0 and has its asymptotes every 90.
That.
Just like that. Now, cot, you can't really do an upside down version of this, so what it does is cot flips around this S shape, if you will, flips around, and then moves it 90 to the right, or to the left, it doesn't really matter.
No, but what happens is the middle of it becomes where the old asymptote was.
Yes, and it's flipped around, so it's not like that. It goes the other way. And that's why cot is quite the surprise. And you'll notice where the new asymptote is where the old centre was, because it's 90 shifted.
So it's not too hard to remember, but it is a little bit weird.
And these are new.
They are new.
And with new things comes new things, of course.
And these things are relationships again.
Yes, so much like your sine squared theta plus cos squared theta equals 1, we've got more, but with these.
Yeah.
And in fact, you start where we left off with the cos squared theta plus sine squared theta equals 1.
So, roll off the graphs. Keeps you fit running off graphs.
Oh yeah. So we start where we left off with this sine squared theta, or x, sine squared x, plus cos squared x equals 1. That's a core 2 relationship you're familiar with. But then we do stuff to it
we do many
to
things.
entwine this stuff.
So there's two different relationships you have to know, and you get to them by manipulating this in different ways.
Although the two ways are very similar, which is kind of friendly.
Yeah.
So first, you divide this whole thing by, say, cos squared theta.
Okay.
Or cos squared x in this case. So you'd have this sine squared x divided by cos squared x. That would just go to 1. Cos squared x over cos squared x is 1. And it equals 1 over cos squared x. Now, two of those things, hopefully, will be ringing alarm bells in your head. And that's the stage you should be at by your exam. Sine squared x over cos squared x is tan squared x.
It is.
And that's the relationship again from core 2. It's just bringing it all together. 1 is 1.
That's the thing you should know.
If you don't, I think you should consider learning.
And then 1 over cos squared x.
This is a new core 3
it's
thing
one
we
of our
just did.
things, and that is sec squared x.
Sec squared x. And that's one of your new rules.
And that's pretty jazzy indeed. But that's not the only thing you can do to that.
No, instead of dividing by cos squared x, you could divide by sine squared x to get a second rule just like this one. So Triv wrote it up again in blue this time. Blue.
Not a very good blue, so can I have your blue?
You can have my blue. It might not be much better.
Damn, let's find out.
You can have
So-
fine pens on this carpet. It's a lovely carpet, but not for pens.
Yes, it's a blended in every colour. Yes, so instead of dividing by cos squared x, we divide by sine squared x. So sine squared x over sine squared x
Is
1.
1. So a similar thing is happening, but it's not quite the same.
And then cos squared x over sine squared x.
Yes. We'll just leave it as it is, like we did in this step. My pen doesn't appear to be much better.
In fact, maybe even worse.
It may be even worse. We'll get out some new blue pens. Equals 1 over sine squared x. Now, it can be quite hard to notice at this stage, but two of those things are a little bit familiar.
A little bit.
This is actually the same as 1 over tan squared x.
Yeah, well, then we've got a thing for that as well.
We do, that's up here.
And that's cot.
And
Because
it's
it's
cot
squared x.
squared x
it would.
in this case. So you've got 1 plus cot squared x, and that one's the hard one to notice. This other one, just like on this side, you should immediately notice.
Yeah, it's just cosec squared x.
Yes. And that is a second rule you must know.
It's quite nice that you can get to these rules and sort of show them for yourself.
Yes. And this is all new, so it's quite
Yeah.
terrifying at first, but hopefully you'll get to a stage where you can just do this and be
Yeah.
ready.
And so this is just where it begins. This is just the knowledge you need to do to be able to solve these equations.
So we're now going to solve the equations now.
We are.
We are.
Do you look different, Wes? Something.
Oh, it's just a haircut.
Oh, okay. It's solving equations.
Yes, so it's using all the stuff we just did, more like what you'll get in an exam paper. So,
Yeah.
where the hell did you get that hat?
Well, I'm not the fool you take it for, Wayne.
That must have been really ninja. Was that when I was ordering that pizza?
Solving equations.
So, we have two nice worked examples that use all of the skills.
We do. So, we're going to go for them.
Yep, shall I read it and you write it up?
Yeah, let's do that. So, what am I writing?
Sec x equals 2, and it's given you a restriction. It's for x is greater than or equal to 0 and less than or equal to 2 pi.
Alright. So, domain. So, to start with, I don't really like sec.
No, and it's always a good step in your exam to get rid of these things and put them back to what you learnt from Core 2.
Yeah, and we know that from on top of there. Sec is 1 over cos x, so let's do that.
Yep, replace it, and then it's all so much easier. So if 1 over cos x equals 2, cos x must equal a half.
Yeah.
And then it's just like you did in Core 2, you should know the stages from here on how to find out what it is in
Yep.
between here.
Just do cos to the minus 1 to find out what other half is.
So, I have a calculator.
Alright.
Do you know how much this cost me,
I,
Troy?
I think I remember vaguely. Was it more than £30?
It was more than £30.
More than £40?
More than £40.
Was it £50, Wayne?
It was 50
Oh my
quid.
goodness me.
Worth it though for this exam. So it's
Oh,
60 degrees. However,
Okay.
we are working in radians. Now, pi is 180, 60 is that divided by 3, so it would be pi over 3
It would be pi over
radians.
3. But we have a slightly bigger range than this, so there might be another one.
Yes, we know what the cos graph looks like. We know how many times, or how many solutions we should have within this range, and it should be 2.
It should be 2.
You could draw it out, that would be a good step in an exam. So there would be another one, and you do 2 pi minus that,
what we have, and
because
that's
of the line of symmetry of the graph.
absolutely
And if that's 2 pi, and that's 1/3, it's going to be 5 over 3 pi. That'll be the other solution at this point. So we have another example. I think you should read it out because I'm going to wear my hat.
Oh. Okay, I'll do that.
So what am I writing?
So solve cot squared theta
Cot squared theta
equals 3,
equals 3.
where theta is less than 100 and more than 180 degrees, minus 180,
Right.
and less than 180 degrees.
Is it less than or equal to?
Yes.
Ah, good. That's what I did. Okay. So I'm going to rub this out because we've done that now.
I've done that one now.
But the steps are all going to be very similar.
Absolutely. So to start with, cot squared theta.
Don't like that
Don't
very
like
much.
that.
Cot is 1 over 10, so I just replace that with 1 over, but it's tan squared theta. Just be careful you don't ignore the square, because you can't. 1 over tan squared theta equals 3. So, if that equals that, then tan squared theta must be a third.
Quite a squeaky pen.
Very squeaky pen. Then you'd square root that, and by the laws of Serge you can root the top, then root the bottom.
You can.
Root of 1 is just 1, so it would just be 1 over root 3. And then you can do tan to the minus 1 of that.
You can, and you should use
However,
your calculator.
Be very careful when square rooting. This should be plus or minus 1 over root 3.
Should be.
And that's something that you've got to be very careful of. So, back to the calculator.
Of doom.
Of doom indeed. 50 quid. Tan to the minus 1 of 1 over root 3. Apologies, I've got to use brackets and stuff, so I'm taking a short while. Is 30 degrees, and we are working in degrees, so that's okay. So we have 30 degrees, you're then going to have 180 minus that 30 degrees. You should know the shape and that it will hit twice.
We're also doing it that side.
Yes, because we have a plus or a minus. So if we do the minus, hang on just a sec, 'cause again I've got to do brackets.
Talk amongst yourselves.
Talk amongst yourselves. If you don't have a friend, we're
Talk
here
to
for you,
yourself.
baby.
Nice.
Minus 30, it's symmetry. So then you'll have the minus 180 minus minus 130.
Which would be a minus 150.
Yeah, symmetry and all that.
It's always good to check because
It is.
symmetry.
And these are two nice worked examples for this. Unfortunately, the chapter doesn't end here.
It doesn't. Now you've learned how to solve them without moving them about. Move about.
They move about.
Yeah,
So,
we'll move the hats
transformations.
about. Let's do that.
Alright.
So, transformations.
Yes, we saved quite a bit of time for this bit, didn't we? We thought this
We
might
had
take
to-
up a while.
So it's quite a few pages and then it's not anything new.
No. We're not going to do any worked examples in this. If you do struggle with transformations, you can check out our chapter 3 video. You
Yeah.
can check out our core 2 transformations video.
It is all the same.
And
Or
you can message us.
Yeah, you can message us any questions or anything. Are you wearing a different hat?
Yes. You see, the other hat I felt was causing a bit of distress at the Clever Cracker studio. Ernest Hassel, the monkey, was getting a bit funny, so I thought I'll scrap that hat and I'll cover it up.
Cover it up.
No, nothing. I'm not covering nothing. I'm not covering nothing.
Like Ash Ketchum. Well, I think this is quite enough of this malarkey. We should get on to a test yourself question.
We should, but first...
You and your bloody hat. Question time.
Yep. Test it yourself. Page 70, question 8 from this book.
Absolutely. In case you're wondering, get rid of the hats.
It was causing a little bit too much stress, and indeed, a few minutes ago, I didn't even want a McDonald's. I was that stressed.
Yeah, I don't know if it was hats, extra salt, or
It could have been excess salt. I
we
suppose.
just had the McDonald's before.
Yeah, we had just had the 5 chicken selects meal with that big burger thing they've got going at the minute with
Yeah.
bacon and cheese sauce.
Anyway, the cause for alarms, we decided hats had to go. So, to confirm this truth, I'll let you read the question and I'll write up the things.
This is true friendship,
There you are.
utter trust. So,
Okay.
do you want to write it up?
Okay.
8a, find in radians the values of the interval. Right, so x is, actually I said minus pi over 2, and then less than or equal to sign, pointing to that.
Thanks.
And then the other way, pi over 2.
Alright.
I always get that wrong in England, I don't know why, I just do. Which sine 2x equals minus a fifth. And then you've got to find the values of x in that interval.
Okay, so finding x.
Yep. So
Right.
we're going to need a calculator.
We are going to need a calculator, we got one of those.
Okay.
Calculator.
So, I'll write up what you tell me.
Right.
It's quite a simple one. You can either divide by 2, then do sine to the minus 1, or you can do sine to the minus 1 and then divide by 2.
Both does
Both
work,
work.
but we'll do the first one Yeah.
Make sure it's in radians.
Yes, that's important because the question asks for radians. You do degrees, it will go interestingly. I think it is in radians. So what we're going to do first is sine to the minus 1 of minus a fifth.
Yep. So either way would actually work. And then you get a value for x, and then it's just like you did in core 2. You should know, well, there's actually a picture of the graph in the book.
Okay, and that gives us minus 0.2.
Minus 0.2.
Yep.
Okay.
And then we just divide that by 2, and that gives us minus 0.1.
Apologies, I thought that was the final answer. No, minus 0.1 as a value for x, but then
Yes.
there's going to be another one in line with it, because
There
the
is.
graph, just in case you don't have our book, you've got that and then that.
And that.
You know what the sine graph looks like, but we've got a value that's going to be about there, so
Yeah.
we should have another one here, in between this minus pi over 2 boundary. So you do minus pi over 2 plus this 0.1,
Yeah.
and it will give you the other answer.
Minus pi. Where is pi? Pi is there. This calculator is quite mean and horrible. Pi over 2. And that gives you minus 1.67.
We'll just say 1.7.
Alright.
Okay,
So,
B part 1 if you want to do that.
alright.
Now it says draw on a single diagram sketches of the graphs with the equation y equals mod x and y equals mod sine 2x in between the same boundary.
So, y equals mod x, and what was the other one, Wim?
Mod 2x, mod sine 2x, which is actually that graph but the modulus of it.
They're both on the same graph?
Yep, please.
Alright.
So you know what y equals x looks like, it's a straight line. And you've got mod x, and from previous chapters, bringing it all together now, you should know that it would flip it up into a V shape. And these ones, it just flips over so it's entirely positive. And then there's a V.
Well, there you are. Okay, now I've drawn those, what's the next bit?
It says hence state the number of times the graph of the curve of the equation y equals sine 2x minus mod x intersects the x-axis in the interval that.
Well, I think it happens there,
Two.
there, 3.
Both of these graphs go to 0, 0, so that's 1 point.
Yep.
So that would just be 3.
Well, there you are.
That's how you answer those questions. They have to be words, you can't be too lazy.
Yep, 3 x-axis interceptions. What's the next bit?
And that's it.
That's
the
it?
end of that question.
Well, there you are.
And if you didn't understand what we did there, please give us a message, because I feel like you were being somewhat sneaky about something and a bit distracted. I don't know.
I felt like you were, but
I wasn't.
no, I'll just forget that and go on to the summary then.
Summary time.
Alright. So, summary time.
Yes, it's chapter 4, it's trigonometry, and it's a lot like trigonometry back in core 2, but then there's a few new things. So in fact, we started with revision.
We started by drawing the sine graph, the cos graph, and the tan graph, and writing the old relationships we knew from core 2, because they come quite healthy later on.
They do, and in fact they immediately became useful because we did all of the new rules. We started off with doing the inverse and stuff, I think, didn't we? Yeah, we did.
Yeah, we reflected it across the y equals x, and those graphs were a little different. They went on to even further different graphs of the new things, the sec, cosec, and cot.
And you've got to know what each of these things equal to, with sec being the 1 over cos, which is quite confusing. Cosec is 1 over sine, and cot is 1 over tan, and then you've got to be able to draw them and know what they look like for the next bits.
Absolutely, and once we got over drawing them, we started solving equations. It wasn't too complicated, there was a few new relationships we knew, but we worked them out by having the old relationship, sine squared plus cos squared equals 1, and dividing one side by all of it by sine squared, and then all of it by cos squared.
Yes, that gave you your 2 new rules. You could just remember the new 2 rules if that's easier, but I find it quite easy because it's not hard maths. So there are 2 new things, and then we did some proper stuff with that, much like we did all the way back in core 2. And the first step is to get these jazzy stuff with the new things that were up in this corner and put it back into what you had in core 2, so the tan, the cos and the sine, and then work from there much like you did in core 2.
once we'd got over all of that, we started talking about transforming them, but it wasn't actually any different to what it was before. So we just sort of skipped over that, went straight to a test sub question, and here we are.
Yes, and as usual, it was an actual past paper question. I think it was from 2002. I can't remember. You can rewind a bit. We did put it up, and it was a proper paper, so it can get that hard.
Yeah.
That's about it for this video.
I think that is
we've done
about it.
Trigonometry 2.
So if you have any more questions, you can send that to us.
On Facebook, you can find us by typing in Clever Cracker Scared. Properly type it in, none of the brackets to the 2. Properly type in, and we should come up. But there's links all over the YouTube channel anyway. You should be able to find it.
So that's that. Oh, rain! It's raining. Got home now.
You know what? I wish I'd brought my rain hat.